4.
All right.
It says, given the graph of the function, this is the function, what does its derivative look like? So the first thing you really want to identify here are the critical points, which is where there's horizontal tangents.
Is there just one here?
There's one there. It's at -2, so we'll put a dot there. There's actually one over here though as well, which is at whatever 1, 2, 3, 4, 5. Like you see how it's basically horizontal there. So what that means is the graph has to either touch or cross at these various places. So you break kind of this up into a window. So what is going on here? Is the graph increasing or decreasing?
Increasing.
So that means you're up above here. That's
Okay.
your derivative. All the way to here, is the graph increasing or decreasing?
Decreasing and then kind of mellowing out.
It's decreasing the whole way, but yeah, eventually gets through. So what that is it eventually comes back to 0.
Okay.
So some graph like that will get you full credit.
All right. I'll write that down.
You could make it smoother than this, but this is good enough.
It would just kind of be like a big old U.
Yeah, I mean the like one, now that you kind of have a sense of what the graph looks like, you might draw something that's more like this.
Sounds good to me.
But these are hard to grade. Is your final exam multiple choice?
Yeah, a lot of multiple choice and a couple of short answers.
Okay. These are obviously hard to grade. And when you've got, a lot of students that are taking exams. So I don't know that they'd give you that. So, all right, find the value of k such that f of x equals kx squared minus 4 natural log x has a critical number x equals 2. So we have to find the derivative of this function. So k is a constant. K is like 3, 5, -2. What is the derivative of x squared?
So this whole thing should probably be like 2kx.
2kx.
The one part, yeah.
Yeah, to the power of 1 minus, what's the derivative of natural log of x?
This is 1/x, so 4 times 1/x.
Yeah, or just 4/x. And you're setting it equal to 0 because that's where critical number, but they give you x is 2. So you have to put 2 in.
For both of those. Okay.
For both of those. So it's 2k times 2 minus 4/2 equals 0. And you have to solve.
So 4k minus 2. And then k equals 2. Oh, no, 1/2.
K equals 1/2. Yeah.
Okay.
So this is a totally reasonable question to ask on an exam.
Looks good to me.
All right, 22.
Yep.
Part A. Rock is thrown vertically upward from the surface of the moon at a velocity of 24 meters per second, reaches a height of s equals 24t minus 0.8 t squared meters in t seconds. So this is like,
Replacement.
You're throwing it up and then it comes back down.
Okay.
But if you were to graph this where t is here and s is here, you'll see a parabola. But you're actually throwing it straight up. But if you actually read the question, I mean, I don't know. Do you ever throw something up from the surface, like from the ground? Like usually I throw it up from wherever my hand is.
Yeah.
Never
taking that.
Nevertheless. Okay. They want the average velocity. So you haven't done this in a while, but this is average rate of change. Average rate of change, or AROC. Okay. And this is A and this is B. So your AROC is f of B minus f of A over B minus A. And I think it's kind of them to kind of like underline average velocity and be like, okay, yeah, here you go. Here's the kind of the helpful formula. So you're going to put this value of 3 into the equation for t. this value of A into the equation for T, and then I'll give you those two values there. And then on the bottom, it's 3 minus 1.
Okay.
Do you have a calculator?
I do not want to have one handy.
All right, so let me do this here. T equals 1, 24 times T minus 0.8 times T
Oh, I
squared.
remember this. It was like a weird question at the beginning of the year.
23.2. Oh, that was 1. So that's actually in the wrong spot. And then for 3, 64.8. So the simplification of this is 64.8 minus 23.2 divided by 2. So it ends up being 20.8. Now, units are important because it's a free response question.
Meters per second?
Meters per second, yeah.
Sounds good to me.
Okay, now the calculus questions are upcoming. So that's part B. Part B is to, let me snip it in here. Part B is to determine the derivative. So I'm gonna graph. I'm sorry, I'm gonna rewrite. So S of T is, let me go grab it. 24T minus 0.8 T squared.
So
V of T is the derivative. What do you got here for me for derivative?
24 times 24 minus let's see. Oh, 1.6 T1.
Yep. Now they want to know when it's equal to minus 12. So you have to set this equal to minus 12 and solve for T.
Mhm.
So you add 12, subtract this, you get 36 equals 1.6 T. Divide both sides by 1.6. Doesn't seem like a great answer.
Not very nice.
22.5 seconds. I can't believe it's in the air that long, but maybe it is. Okay. Okay, so part C. Did you get some of these motion problems in your calculus class?
Like one, probably.
Okay.
I think it'll be on there though. They'll just like throw one random one in there.
Sure. So the maximum height occurs here. So so that's actually when velocity equals 0. So you set V of T, which is 24 minus 1.6 T, you set it equal to 0.
Okay.
And then you solve for T. So 24 equals 1.6 T. And then we divide both sides by 1.6.
Oh,
And
okay.
you get T equals 15 seconds.
All right.
So that's this right here. That is not the max height. That's just when the max height occurs.
Okay.
If it asked for the max height, you would put this number back into the original, not the velocity, because the velocity is 0 there. We want to know its position. Velocity is 0 there because it's a horizontal tangent.
Okay. That makes sense.
Part D asks for the max height. Shocking. So it wants you to evaluate S of 15
Mhm.
because it wants to know how high. So that's 24 times 15 minus 0.8 times 15 squared. Go back to my calculator. Get back to, we said 15, right? 24 T. Yeah. So that's 180 meters.
Okay.
All right, I'm just looking at 21 here before I present it to you to kind of know what's going on here.
Okay.
So yeah, so this is what they're trying to do here is help you out. They're trying to say like this first region, we don't know what the curve is, but we know that it's 18.8. This is 34.4. And this is 66.8. Okay.
All right.
So there's a variety of questions here. And the first one is part A is the integral from 0 to 5. And this is f of x,
Okay.
dx, f of x dx. So 0 to 5, we assume that's 1, 2, 3, 4, 5. Okay. So here you've got an area above 18.8. Areas above the x-axis are positive. Areas below the x-axis are negative.
-30. Okay.
So just subtract those two.
All right.
So the integral can be negative. It's possible.
So that
that's-
substitutes for the f of x, right? Like when you put it in the
Well,
calculator.
Well, no, you're just using these numbers. You're using the definition of like, what does this integral mean? It means the
Oh.
area under the curve. So it's positive here, but then it's negative down here.
Mhm.
Okay, so the next one here, it says the integral from, what is it? 0 to 8. So part B is the integral from 0 to 8 f of x dx. So again, you've got areas above. You've got that 18.8 above, area below, and then you
Plus
add the area. Yeah.
66.8. So -15.6 plus 66.8. I get 51.2.
Okay. Yeah, give me that one more time, sir.
I got 51.2.
Yeah, okay. All right, and then the last one, these are weird. Oh, okay, so the last one's probably the hardest. It's a bit odd. It's 8 to 2 f of x dx. So notice it's always increasing, lower limits on the left, top limits on the right. Here you're going backwards. You're going from 8 to 2. So the rules switch. So the areas above the axis are now negative, and the areas below the axis are now positive.
Okay. Wait, so like, why is it backwards again? Can you say that one more time?
Well, when the order of integrations are reversed, you switch the thinking.
Oh, okay.
So if this were 2 to 8, it would be positive 6. So let me actually write that below here so you can see the difference. If it were 2 to 8, f of x dx, it would be 66.8 minus 34.4.
Okay, that makes sense.
But because it's flipped, you have to flip everything. Now, if this were multiple choice, you would see both answers potentially.
Mhm.
Like I would, just because that's all you're testing is like, do you understand this?
Okay. Makes sense. Is there any
Alright.
more questions for this, or can we go to
No,
the next one?
that's it for that. We can go to 20, question 20, which is not a good question. We need to actually give you a function so you can see what's going on here. All right. What do we want to do here? Let's go. Let me just quickly graph something here and see if that one's now gonna be a little tough. X natural log of x. That one's got an inflection point. It does not. Darn it. Okay, so I use this one. This isn't my favorite, but it will get the job done here for us. So to determine an inflection point, you have to take two derivatives.
Okay.
So this is a product rule derivative. So it's first times root of the second plus the second times root of the first, which is 1. Then you have to take a second derivative. So the derivative of x e to the x is like this first part. It's all of this. And then the derivative of this is e to the x.
Wait, the derivative of e to the x is e to the x? Is that what
Yes,
you're
is
saying,
itself.
sir?
Yes,
Oh,
yeah.
okay.
But I want to just cut through this because I want to get to the part where we actually can can work on this. So let's factor out an e to the x, and you get x plus 2.
Yeah.
Well, now when you set this equal to 0, x plus 2 equals 0, x equals -2. So when you put this on a number line, you end up getting that this is negative and this is positive. So this is an inflection point. It's an inflection point because the second derivative, f double prime of x, switches sign. Minus to plus or plus to minus.
Yeah, inflection points, yeah.
Yeah. So that's the criteria. The criteria is you have to see a switch in this. It also has to be continuous and differentiable and all this other stuff. But I think they're looking for this, like you to understand that you have to take a second derivative, do a sign chart, and see a switch in the sign.
Sign switch. Okay.
Actually, I got the answers. So I'm gonna go look and see what your instructor has to say on this one. Yeah. So it's the second derivative being 0 and then seeing a sign change. But you're not going to be asked for you're not going to be asked this question. Like this is not an exam question. This is a study guide question where they want you to do a question on an exam like this and be able to set it equal to 0.
All right.
I'm going to just step away for 30 seconds, but I'll be right back and we can continue with question 19. All right, I'm back.
All right, that's fine.
Okay, so let's look at 19.
So we gotta find the antiderivative of this and then evaluate it at 9. Value f of 1 equals 9.
Yeah, you're finding the antiderivative of each. So what you might want to do is you might want to rewrite this slightly like this.
Oh yeah, it's true.
To help.
So it looks like the antiderivative will be like
So you add 1 to the exponent, so it becomes x squared over the new exponent like this. The third one is more like the first one, so we'll do that one next. You add 1 to the exponent, divide by the new exponent. The middle one is a special case. So there's a few antiderivatives here that you need to know. The one we've been doing is the integral x to the n dx is x to the n plus 1 over n plus 1. And then 1 over x dx is always the natural log of the absolute value. Yes. Okay. So this is plus 4 natural log absolute value of x. So with some simplification here, you can see that it's 2x squared plus 4 natural log absolute value of x plus 4, because those cancel, over x plus c.
X plus c. Okay.
Now you have to be able to find the value of c from this initial value that they give you. So this is 9 equals 2 times 1 squared plus 4 natural log of 1 plus 4 over 1 plus c.
Sure.
So it's 2 plus natural log of 1 is 0 plus 4 plus c. So c ends up being 3. And then you write that back in this line right here.
It's a natural log of 1 is 0.
Yes.
You don't multiply it by 4.
4 times 0 is 0.
Oh, okay.
I maybe it wasn't clear. I brought this 4 down.
Oh, that 4, okay. I was kind of tunnel vision, I guess.
Yeah.
All right, 2 plus 4. All right. That makes sense. Do you do anything else, or is that just it?
I mean, that's your final answer. Your final answer is you put this value of 3 back in this line right here.
Oh, all right.
Do you want to do one like this, but maybe less difficult?
Sure. I'll try to could you maybe like just give me a problem, I'll try to write it out and let you know what I get.
Yes. So let's say, let me go back and look at it one more time. So let's say f of x equals, equals 3 over x plus 3x squared minus 3 over x squared, and f of 1 equals 2.
All right. So basically just 3 ln of, is it ln of x?
Yes.
Absolute value of x? Okay.
Absolute value. It really doesn't matter in your class. Not a big deal.
Mhm. All right, so it looks like. So is that one just x cubed for antiderivative or no?
Yes, it's x
Okay.
cubed.
And so then it's minus 3 ln x squared, or how does that work?
So again, this is why you got to rewrite it. It's 3x to the minus 2.
Plus 3x minus 2.
Yes.
Oh, okay. 3x minus 2. All right, and that's a -3 in front, so it'd be what would it be? Oh, is it just minus x cubed again?
No,
No.
what did we do in the previous problem here? What did we do right here? How do we go from this line, 4x to the minus 2 to this line?
So,
You always add 1 to the exponent and divide by the new exponent.
oh, okay, so it's plus plus 3.
Okay, so it does change to positive, but what happens to the exponent?
Oh, it turns to a cubed. Is it plus 3x cubed?
You're adding 1 to the exponent.
Oh, sorry, it was just 1, so plus 3x.
It's negative. You're adding 1. It's -1.
Oh,
So Jack, like this is what I'm trying to get you to do. Add 1 to the exponent, divide by the new exponent. You've got to be able to do this. Like, and if you need to write it out, write it out. Like they don't care when they're grading this. They don't care if you do that. They care that you get the right answer. I'm trying to say there's no like shame or anything if you have to write out these steps. So that's plus 3 x to the minus 1 or plus 3 over x.
okay.
Okay, now how do you use this for over here? Well, it's really plus c plus c. So you got to put that f of 1 equals 2 in and see if you can come up with the c value.
2 on the right, and then 1 instead of the x for all these. So ln of 1 is 0, right?
Yes.
So then that whole thing is 0 plus 1 cube, which is 1, plus 3 over 1, which is just 3 plus c. So 3 plus 1, 4 plus c equals 2 minus 4, I get -2 for c, and I plug it back in. Is that what I do? Is that what I do now?
You just put that c value, which is -2, back into this line right here.
Oh, all right. So back into the antiderivative. So f of x equals 3 ln x plus x cubed plus 3 over x plus, well, minus 2.
Yes.
All right.
If you have time later, those 2 problems would be good to look at again and get much faster, especially at the power rule. You're going to get a few of those on your exam. Okay, a survey shows that a mayoral candidate is gaining votes at a rate. That's very important. What does rate mean in terms of calculus?
Oh, that means derivative. Oh, okay.
Derivative. Yep. 20t plus 10 votes per day, t blah, blah, blah. Okay. How many supporters will the candidate have after 30 days? Okay, assuming that she had 500 votes when she started. So they're giving you an initial condition. They're telling you when t equals 0, the number of votes is 500. That's like your initial condition.
Okay.
So you've got to be able to find the antiderivative of this, the 20t plus 10. What's the antiderivative of that?
So 20t. So it's 1 plus 1, then divided by, what would you divide it by?
The new exponent?
Oh, the new exponent. Okay, so 2. Okay, new exponent plus is it 10x or 10t?
10t in this case, yeah. And then there is a c. So your c ends up being 500, but what I would tell you to do as a calculus student is to still plug it in. 500 equals 20 times 0 squared over 2 plus 10 times 0 plus c. Because you don't want to take a chance that you get the wrong quantity, because you think, oh, it's always c. C is always the initial condition, because it's not. It's not always.
So 0 plus c with
But these are both 0.
0. Okay.
Okay, so that goes back in here. So the votes as a function of time is 10 t squared plus 10t plus 500. And the question asks, if we go back up, sometimes we're going to go back. It says, how many supporters will the candidate have after 30 days? So that means t equals 30. You need to find v of 30. Like that. That's a huge number. You need a calculator for that.
300 plus 500. I get 9,800.
Sounds reasonable. That's 900. That's 9,000. Another 300. Yeah, 9,800 votes. All right. Let's look at 17. Seventeen has 2 parts to it. Forest fire spreading in a very, very remote area at a rate. What does rate mean?
Derivative.
Derivative, yes. Okay, that means you're going to integrate this. Okay. So what is the antiderivative of r of t? Well, it's 138 t squared over 2 plus 50t plus
Okay.
c. Now, what is the initial condition? It comes from this second sentence here.
If the fire already burned 200 acres when it was first discovered, so C is supposed to be 200, so you can do, if you
Yeah,
want to check up on it, you can do, what was it? R of 0 equals 138 times
r 0
0.
equals 200. Yeah,
Oh.
so exactly right. You have 200 equals 0 plus 0 plus c.
All right.
Okay, so then they want to know, well, how many burned 2 days later? So they're telling you that t equals 2.
So you plug in 2 to the antiderivative, right? Right here.
Well, yes.
100 plus 200, 300, and 2 times 2 is 4. 69 times 4. I don't know that. 69 times 4 is 276 plus 100 plus 200 is 576. Should be.
Sounds good to me. So part B is actually completely unrelated, which is odd, the way that they did this. Like they just put a question in here. It's okay. The energy expended by a bird is given by this function. Actually, find the value of f that will minimize the value of e. Okay, basically they're saying what is the minimum or maximum of this function in this case, it's minimum. So there's nothing to do with the last problem. Just keep that in mind. So you have to be able to take a derivative, e prime. And again, I would recommend that you rewrite this as f to the -2 power
All right.
for your antiderivative, or for your, I'm sorry, for your derivative, not your antiderivative. So your derivative is 0.25 minus 3.4 f to the -3 power. So Jack, is often at this point in the course where students misuse their derivative and antiderivative rules. When you take a derivative, you subtract. When you take an antiderivative, you add. It has to be that clear. You have to be able to wake up in the
Right.
morning and know this really well before you've
So-
had your coffee.
So say that one more time.
Well, with derivatives, you subtract exponents, and with antiderivatives, you add.
Subtract exponents. Anti. Add exponents. I just want that to be completely clear.
Yeah. So the next thing here is to set this equal to 0 and solve for f. So you're rewriting this is good. It's almost never good to deal with negative exponents. That's why they emphasized it in previous classes. So when you move some things around here, you get 0.25 equals 3.4 over f cubed. You can cross multiply 0.25 f cubed equals 3.4. F cubed equals 3.4 over 0.25. And then you take a cube root of that. So f is the cube root of 3.4 over 0.25.
Okay.
Now you're supposed to actually check that it's the critical point, but since they're asking for it and it's the only one, like if this were multiple choice, I'd probably just answer it. But if you like had to show your work, you'd want to show that this is a critical point with a sign chart. But I don't think we need to do that. I'm just sort of making an observation about the question.
Mhm.
All right, instead of doing 15, we should do an example that would use 15. 16 I'm skipping because it's drawing a graph, which you said before wasn't really emphasized. Okay, when a function is concave up, what does that tell you about the first derivative? So here are two possibilities. Is this concave up? And is this concave up? Do they both hold water?
Yeah, they both hold water.
Okay, kind of. Yeah, I mean, that one should be there. So what would you, if you were to, this one is considered decreasing on the left. And this one is considered increasing.
All right.
So just being concave up, is that enough to tell you whether it's increasing or decreasing?
With concave up, is it enough to tell you?
Yeah,
Um,
because it could be this one or it could be that one, right?
well, it's
Which
not
one?
complete. It's not 100% specific, so no.
It's not enough. No, it is not enough. You need to be absolutely sure. And no, I mean, you know, someone's life's depending on something, you better know which way it is,
Mhm.
right? So I don't know why this is here, but the way we would use this is, let's just say y equals x cubed minus 4x squared. 3x squared. Okay. What is the first derivative?
The first derivative here is 3x squared minus 3x.
6x. What is the second derivative?
6x minus 6.
Set it equal to 0. What is x? What is the critical point or inflection point?
Inflection point should be 1.
1. Okay, now let's go back. That was we didn't actually need to do that part, but let's go back to this one. Let's set the first derivative equal to 0. So you'd factor out a 3x from both, and you get x minus 2. So there's actually two critical points. There's one at x equals 0 and one at x equals 2. Did you talk about the second derivative test in your class?
Can you explain a little bit?
Okay, here's how the second derivative test works. If f double prime of a critical point is greater than 0, you know that it's a min. If f double prime of c is less than 0, you know that it's a max.
Oh, yeah, I think we've talked about that. Yeah.
So when you put 0 in for x, what is the value? 6 times 0 is 0, minus 6 is negative. So 0 is f double prime of 0 is less than 0. So this is a max.
Okay.
When you put 2 in, 6 times 2 is 12. 12 minus 6 is 6. It's greater than 0. So this is a min.
Oh,
And I
all
think
right.
that's what this question is like trying to get you to see, but it's very done very poorly. I mean, I don't even know who could have written something like this. It definitely wasn't someone. Yeah, it's confusing the way it's written. So, okay, I know last time we did 14A and B. I think we did 13 also. I know we skipped some of the word problems because they were hard to write. So let me go back to some of these earlier ones that were hard for us to look at. So we'll start at number 1 here. How do you feel going into the final, Jack? Or what do you think?
I still kind of want a little bit more like practice.
So you don't feel you're not like confident. You're like, oh, I got this. You know, I can do it. Or meaning like you're gonna go in there. It's gonna be you know everything. You feel really good.
I feel okay. I just
Okay.
kind of I just want to do a little bit more practice on stuff that we've done already. Just kind of get iron in my head.
All right, sounds good. So it says during a long distance driving trip, after filling up your car with gasoline, you notice that when you have 12 gallons of gas remaining in your tank, you have driven 162 miles. And that you have 5 gallons of gas remaining after having driven 330 miles. Assume that this relationship is linear. That's important.
So constant.
Yeah, basically they're saying like you need to be able to find the slope. So we'll do that. Write a linear function that would determine the number of miles n you have driven in terms of the number of gallons g of gas left in the car. So what's very important here is whether you need to tell me which is the x variable and which is the y variable, basically, which is the input and which is the output. That's the key part of doing this question.
Is the miles the input the x, or are they the y? I don't.
Well, I mean, that's the that's the key thing here. You got to look at when it says in terms of is the independent, which is g.
Oh, okay. So the gas is the x.
Yes.
All right.
Yes. So getting this wrong makes the rest of the problem wrong. So this is why it's so important. Like if this were a 20-point question, you needed to get this right to move on, I would take the 2-point deduction to like make sure you had it right, because you can't even proceed. So your ordered pair is g comma n. And the first ordered pair is 12 comma 162. The second ordered pair is 5 comma 330.
Mhm.
Do you follow how I got that from the information given?
Yeah, I do.
Okay, so we need to find the slope. Slope is 330 minus 162 over 5 minus 12.
Oh, 5 minus 12. Okay.
Well, it's y2 minus y1, x2 minus x1.
It's 168 divided by -7. You get -24 with this.
Yeah. So now a lot of equations you can write. I would actually write it like this and then substitute the variables the ones they're using, because this is what we're used to. We're used to X and Y. So minus 24, and I'm going to use this top point. Y minus 162 equals minus 24, X minus 12. And then we want to solve this for Y. So minus 24X minus 24 times 12. I don't know that. 12 to, was it 288 maybe, plus 288?
I get 288, yeah.
Plus 162. So Y equals minus 24X plus, what is that?
450.
450, yeah. Now when we use the variables, G and N, so this is N equals minus 24G plus 450.
All right. Looks good to me.
Okay, so that's important. You got to be able to get that. Now we can actually like answer some questions. Okay, so again, I don't know how they have you do this on a final, but like in other classes, they give you multiple choice answers for interpret. Interpret the slope of the linear function. So the slope is negative 24, but what does that mean? What are the units of the slope? And it's the Y units over the X units.
Okay, so the input is the gas, right? And the output is the miles.
Let me go look. G is the input, G is gallons,
Mhm.
and is miles. So miles per gallon.
All right.
And I think what they're trying to do is give you a problem that you should have some association with in real life. You drive a car, you fill up with gas, it's in miles per gallon.
All right. That's fair.
I guess. So it says it's going down by 24 miles per gallon. So for every gallon, like you use up 24 miles of this 450.
24 gallons per mile, miles per gallon. I mean, so that's how that goes. Or
Well, it's going down. So the number of miles you can drive with a full tank is 450.
okay.
Every gallon you use reduces that by 24.
Mhm.
I now this is it's an odd question. I mean, if you're not fully getting it, it's written a little wonky. So how many gallons does the gas tank hold? So the answer is not 450. 450 is the number of miles. But if you divide it by 24 miles per gallon, the miles cancel and the gallons come up here.
What about 24? I get 18.75 for this.
Yeah, 18.75 gallon tank. Have you looked in the owner's manual of your car? Your car's not full electric, is it?
No.
Okay, so in every owner's manual, or just got to the internet, you get the full capacity of your tank, and you've almost never filled up this amount. I mean, if you did, I mean, you ran out of gas, because the gauge is designed to not tell you that you're at zero, because then you truly would run out of gas. So you've probably never put whatever the full amount is in your car, and I haven't either. Like, I mean, it's you don't do that. We don't do that, but it's interesting. The gauge will tell you you're on E, and you're not. You're on you have a little more left.
Yeah, you don't ever want to get all the way down. That's not right.
Yeah. But people do. I think if we interviewed a tow truck driver, he would say that a lot of a lot of calls are for running out of gas.
Oh yeah.
Yeah. All right. Below is the graph of a function f. So we got a bunch of sort of things here. Now they're talking about f. They're not talking about the derivative. Okay. So let's answer all the problems about f, which I guess is a, what kind of, I'll just a. Where is f of x less than 0? This means below the x-axis. Well, it's here, right? It's
Yeah.
here, and then it's here. F
So-
prime of x equals 0 means that it's a horizontal tangent.
Is that just B and D? So like
B and D, yep.
2 and 4?
We'll say B and D. We can that leave it like that.
Oh, okay.
Now, F prime of x greater than 0 means it's going up and to the right,
So it's only doing that like,
up and to the right,
um,
and then up and to the right.
oh, so A to B and B to
No,
infinity
D,
or
D,
whatever.
D, D
D
to,
to infinity.
yeah,
D to
B
infinity.
to D is where it's decreasing.
Mhm. Yeah, that's true.
So F double prime of x greater than 0 means it's concave up. Where is it concave up holding water? So it looks like
Only
it's,
C to infinity.
yeah. And then concave down the other way.
Mhm. True.
Let's look at this last one. Where is F prime of x the smallest?
F-
So that means most negative. Where is it decreasing the most?
mm,
So I
What?
would argue it's here.
A
Because
to B.
I'm sorry, decreasing, wrong way. Here, it's decreasing here.
Oh, all right.
All right, good. Now, if it asked for the greatest, it would be probably over here where it's going up and to the right a lot.
Okay.
And then F prime decreasing is another way of asking concave down.
Just only at A to B or A to C.
A to C, yeah, somewhere in there. So you would probably get a couple of these on an exam. You wouldn't get all of these, but they're all sort of in play. Like you need to know all of them. And we actually didn't even do all of them. There's f of x less than 0, f of x greater than 0, f prime of x equals 0, less than 0, greater than 0, f double prime of x equals 0, less than 0, greater than 0. And then kind of these other ones where they say f prime of x increasing, decreasing, largest, smallest. Like there's what do we got here? 5, 8, 12 different questions you could ask on one graph.
All right.
So just keep that in mind. All right, well, that does take us to the end of our lesson for today.
Mhm.
Thanks for scheduling, and let me know if you need some help for your final exam. I think you said it's on Thursday.
Yeah. Do you have any like in-person lessons tomorrow?
Yeah,
you
go
could
ahead
do?
and text me. I am traveling, so I'll let you know when I get in what my availability is, because it depends if everything goes to plan. So it would be early afternoon,
Early
mid
afternoon.
to mid afternoon.
I could do that. That's perfect for me.
All right.
Well, thank you for your time and I appreciate it. Have a great day.
Okay. Bye.
Take care.